All right, so we're going to do some maxes and mins. This is going to be section 12.3. And we are going to do maxes and mins. Some of it we're going to do on our calculator. Some of it we're going to have to do by hand. So first of all, an absolute max or an absolute min is simply the tallest point or the lowest point on the graph. So if your graph is like this, where it goes on for all eternity, okay, so that's what those little arrows mean. It means it'll never reach a very, very, very tallest point. So in that case, we have an interval going from -6 to -1. So I'm okay using points all the way from here, which is -6, all the way over to -1, which is going to be right here. So I'm only interested in the graph that appears between these two graphs, or these two brackets. So the question is, do you have an absolutely tallest point on that? Well, I should, because if I look, the very tallest point on that interval is going to be at -6, 0. So at -6, I have a maximum value. The maximum value is 0. So you have to be careful how it's being phrased. The maximum occurs at x equals -6. The minimum occurs where? Well, don't fall into the trap of, well, it must be on the other side, because my minimum here at -1, which is the far right of the interval, would be right here at -4. But does the graph go lower? Yes, it does. It actually bottoms out right here. So what x value does it bottom out at? It bottoms out at an x value of -3. So what you could say is you have an absolute min at -3, and it happens to be -9. So when we ask you for locations, we're asking for x values. If we ask for values, we're asking for the y coordinate. Okay, so let's do it again. Find the location of the absolute max and the absolute min going from -1 to +1. So here is -1 right here. So this is where I'm interested in starting. And here is +1 right here. So that's where I'm interested in ending. So on this interval, do I have a very, very, very tall point? Yes, I do. And it occurs at -1. So I have a max at -1. It happens to be a value of +1. Do you have a minimum? I have a minimum at +1 because that's where the thing bottoms out. Okay? So that means you can do number 3. And all right, so here we go. We have find the locations of the absolute extrema. Remember, extrema just means maxes and mins. Okay, the extreme values of the functions on the given interval. So I want to go from 0 to 5. I've got 4/3 x to the third. So 4/3 x to the third minus 2x squared minus 48x plus 8. And I'm only interested in going from 0 to 5. Okay, so what do we know so far? Do I see any variables in denominators? No, I do not. Do I see any variables in radicals? No, I do not, which means right now, my domain is all real numbers. Okay, so step 2, take a derivative. So drop your 3 out front. That'll give you a 12 over a 3, which reduces to 4. So I have 4x squared minus, drop it out front, minus 48. And then set that equal to 0. Well, I can divide a 4 out of everything. So divide out of 4. So I've got an x squared minus x minus 12 is 0. And now this is factorable. It was factorable before, but it was ugly. So two numbers that multiply to -12 that add up to -1 are a -4 and a +3, which means this value is 4. And this value is -3. Okay, so what numbers are we interested in? I'm only interested in anything between 0 and 5. Okay, so I found out 4. I got to try a 4 as well. -3 is way over here. So -3 is not going to be anything that I'm interested in because I restricted what numbers I'm interested in. So I got to try 3 numbers. 1, 2, 3. I have to try 3 numbers and figure out if they're a high spot or a low spot or someplace in the middle. So if you grab your calculator, we can go into y equals, I've got a 4/3 x cubed minus a 2x squared minus a 48x plus 8. And I'm going to graph it after I make sure that my window is normal. So I want to zoom standard. And let's just watch and learn. All right. So he's pretty much done. So here's what I want to know. I would like to know, first of all, I really can't see what's going on here, so I'm going to change my window. I need to make it squish in this way. So I need to adjust the y's. So my y max, I'm going to make into a 50 because I don't know how far it goes. And I'm going to make my y min a negative 50. And just try it again and see what happens. Just because I want to see a better picture. And remember, I only care about between 0 and 5. Okay? So now I can find out what the values are. I have a very basic idea of what this thing looks like. So I want to know, if I hit second calc, what is the value at 0? The value at 0 is 8. So right here, I've got the 0.08. I would like to know what is the value at 4. Okay, and that's a negative 130 and 2/3. Okay, so at 4, I'm at a negative 130.7. And then what is my value at 5? And at 5, I get a negative 115. So at 5, I get a negative 115.3. Okay, so the question is, who's the tallest? 8 is the tallest. Okay, so he's going to be your absolute max. And where's the lowest point? Your lowest point occurred at 4. So when we come back over here and look at this, that's the wrong one. All right, when we come back over here and look at this, it says, where is your absolute min? Your min occurred at 4 because that was where the very, very lowest point was on the graph. Where's your max? Your max occurred at 0 because that's where he spit out the very, very tallest one. Okay? So this is literally what you're going to do for the rest of it, is you're just going to go and find out maxes and mins. So on this one, your interval is from 0 to 100. You are not interested in evaluating at 0 because it is a soft bracket. So from 0 to 100. All right, so we're going to look at the average cost. So it says the daily cost is this. So I've got a 0.06 x to the third. And then a minus 6x squared plus a 178x. That is your daily cost. But I want the average cost, or I want bar C. So bar C of x, which means I'm going to divide everything by an x. And that we've done several times throughout last semester and this semester. So average cost means divide everything by x, which means my new function is 0.06x squared minus 6x plus 178. Okay, so that is my new and improved function. I don't have any variables in denominators. I don't have any variables under radicals. So I can just go ahead and take a derivative and set it equal to 0. So this, drop your exponent out front. Minus 6 is 0. So I'm going to add 6 to both sides. So 0.12x equals 6. And then divide both sides by 0.12. So 6 divided by 0.12 should be 50. Yay! So if x is 50, that's going to be your lowest average cost. How do I know it's the lowest? This makes a parabola. He's a parabola that opens upwards, and you just found out the minimum value. So when x is 50, you're going to have the lowest average cost. And then what is that lowest average cost? or the minimum average cost. You're just going to take that value. If you ever want to know your original y coordinate, go back to your original function, which is this one, not this one, because this is the average cost function. Shove in a 50 in there, and you will find out that it is $28.